Alright, here we are on our fifth and second to last part. It might be the last part depending on how much room I end up taking up. So, I wrote down this equation. It was one that we got earlier in one of the previous parts. And what we are going to do is we are going to take the t that we just solved for in the previous part, and we are going to plug it in right here to this t. So by doing that, we are going to get the integral from p2 to p1. And then we are going to have p over p, which is to the power of gamma minus 1 over gamma, if I can write it right, okay. And then this is going to be over p. And we still have our dp. And this is equal to, obviously, the same thing we have over here. This hasn't changed. So negative mg, I'm actually just going to write the dz up here. All of that is over r. Remember the dz being the change in altitude. So then our next step is we are going to pull out the t. We want to get it into the front. So our equation will now look like t1 p1. And that's going to be to the power of 1 minus lambda over lambda. And the reason this changes is because we are taking it outside of the integral. That's why it flips. And we'll still have our integral p2, p1. But this is going to change up a little bit. So this is going to be p, just our basic p. And it's going to keep the same exponent from before. Lambda minus 1 over lambda. And then this is also going to be subtracted by 1. And then we'll have our dp, which stays. And then it is equal to, same thing as before, negative molar mass times gravity times the change in position over r. Now, we are going to get all of the we're going to get all of the coefficients on the same side. So we are just going to basically move this over here, and we are going to move this over here. So that's going to look like we are going to have our negative mg dz over r. And then that is going to be multiplied by our this right here. And because we're dividing, getting it on the other side, the coefficient is actually going to switch back to the lambda, or gamma minus 1 over gamma. So we'll have that being multiplied by t1 p1 times gamma minus 1 over gamma. And that's going to be set equal to our integral p2 p1 p. Oh, excuse me. Where am I at? Here we go. Lambda gamma minus 1 over gamma dp. Now we are just going to integrate this part right here, our p2, or the thing that just needs to be integrated, which will end up looking like, we'll have p with lambda minus 1, gamma minus 1 over gamma, and then this is then also going to be over gamma minus 1 over gamma, and we will be evaluating it at p2 and p1, which will then equal to p2 gamma minus 1 over gamma minus p1 gamma minus 1 over gamma to the power of, and then this will all be over gamma minus 1 over gamma. So now we will be able to multiply the gamma minus 1 over gamma to the other side, which we have over here. I just took this little section and just solved for it just to save a little bit of space. So our formula now is going to look like this. We are going to have P2 gamma minus 1 over gamma minus P1 gamma minus 1 over gamma. And this is going to be equal to, this is the big long one here. We'll have mg delta z. All of this is still over r. And now this is going to be multiplied by still the T1 P1 to the power of 1 minus gamma over gamma. Oh, yes, that is correct. That is correct. Multiplied by gamma minus 1, this thing right here, over gamma. And now we are just going to combine like terms. So let me do that real quick. So we are going to bring, we're going to bring the P1 over to the other side. So that's going to end up looking like P2, still keep the same exponent, gamma minus 1 over gamma, is now equal to, like I said, we were bringing the P1 over to the other side. P1, same exponent, gamma minus 1 over gamma. And now this is going to be multiplied by 1 minus, and then we are just going to, because this will be factored out with the 1, so we're just going to have the mg dz over r times gamma minus 1 over gamma. Like I said, over r, and then multiplied to our gamma minus 1 over gamma. And now we are on to our last step. We are just going to move the gamma minus 1 over, and this gamma minus 1, this gamma minus 1, we're going to move that over here so we can just get our P2 alone. And we are going to then have P2 is equal to P1 multiplied by 1 minus mg delta z all over r still. And we keep the gamma minus 1 over gamma. It doesn't move anywhere. But then from the gamma minus 1 over gamma from the P2 will now be the exponent up here. So we'll have gamma minus 1 over gamma. Right here we have our final pressure equation. So this is the 1/2, this is the pressure. We still need to get temperature. So I will solve for that in part 6. All right, see you there.